Hello everyone, Jai Hind, and today I'm going to explain the topic of multiple cores and multiple threading in operating system. We left off from the previous lecture. I told you about the relationship between threads and processes. So if you want, I can give you a revision. You can go through this again. A thread to process is a one-to-one, many-to-one, one-to-many, and a many-to-many kind of relationship. How is it so? Since a thread of execution is a unique process with its own address space and resources. Since a thread has its own address space and its own resource, so that is why we can say that it is a one-to-one relationship. Similarly, I told you that it is also a many-to-one kind of relationship between a thread and a process. Why? A process defines an address space and dynamic resource ownership. Multiple threads may be created and executed within that process. A single process can have many threads. So that is why we can also say that it is also many to one kind of relationship. The other one is a one to many relationship between thread and process. A thread may migrate from one process environment to another. This allows a thread to be easily moved among distinct systems. A thread moves in many in the system at wherever it feels like. It can switch between different environment in a process. For example, clouds, emerald. And I also told you that a thread to process is also a many to many kind of relationship. Since it combines the attributes of many to one and one to many cases, we can say that it is also a many to many kind of relationship. Now let's start with multiple cores and multi-threading. Multi-threading and multi-core chips have the potential to improve performance of applications that have large amounts of parallelism. What I am trying to say here is that there are chips, multi-core chips or multi-threaded chips, which improve the performance of applications which have large amount of parallelism. What happens in a parallelism is that multiple processes or multiple threads get executed concurrently at the same time. Gaming, simulations, etc. are example. For example, in simulations, performance doesn't necessarily scale linearly with the number of cores. Now, what is Amdahl's law? Speed up depends on the amount of code that must be executed sequentially. What is the formula of Amdahl's law? Speed up equals to time to run on single processor divided by time to execute on n parallel processors. For example, which is equals to 1 upon 1 minus f plus f divided by n, where f is the amount of parallelizable code. So this is what we call as define as Amdahl's law. Performance effect of multiple cores. Here you can see that there are in figure 4.7a and in figure 4.7b. So there is a graph plotted between relative speed up and number of processes. Okay, and this graph is between relative speed up and number of processes, but with the speed up is with overheads. This is the speed up with 0%, 2%, 5% and 10% sequential portions. Now how you will explain this graph? That whenever the relative speed up goes up to 0%, okay, up to level 8. Similarly, your number of processors increase. Okay, now here's the difference. Here you can see that there is a parabola kind of which is displaying the different percentage of 5%, 10%, 15% and 20%. Now, database workloads on multiple processes hardware. Here you can see this is the scaling and this is the number of CPUs. Scaling of database workloads on multiple processor hardware. Here you can see that this is a Oracle DSS 4-way join, and the second one is TMC data mining, third one is DB2 DSS scan and aggregates, fourth one is Oracle and HOC insurance OLTP. Now these are the applications that benefit MCD 006. Multi-threaded native applications characterized by having a small number of highly threaded processes. Multi-threaded native applications, what do? They are being characterized by having small number of highly threaded processes and multi-process applications. So there are two kind of applications. The first one is multi-threaded native applications. The second one is multi-process applications. Multi-process applications are characterized by the presence of many single-threaded processes. Multi-threaded native applications are characterized by having small number of highly threaded processes. There are many threaded processes present in a multi-threaded native application, but there are many single-threaded processes present in the multi-process applications. The third one are Java applications. Multiple instance applications, of the application in parallel. There are multiple instances of any application present in running in parallel. Windows processes and services provided by the Windows kernel are relatively simple and general purpose. Now, Windows processes are implemented as objects, and these are created as new process or a copy of an existing. An executable process may contain one or more threads. Any executable process can contain one thread or many threads. Both processes and thread objects have built-in synchronization capabilities. Since why do we need synchronization? We need synchronization so that the race condition does not happen, right? So both processes, there is synchronization present in processes, and similarly there is synchronization also present in threads. Okay, so what I am trying to say here is that whatever the services that the Windows kernel provide to the processes are relatively very simple, and these can be implemented as objects also. And any executable process contains many threads. Now, relationship between a process and a resource. What kind of relationship is there between a process and a resource? Now, this is a process object, and these are the virtual address descriptors. Okay. Now, a process object has to have a access token so that it can handle different kind of threads. Here you can see these are thread X. It has the file which is present in the file Y, and it is present in section Z. So this is your handle table. What is happening here? A Windows process. Here you can see this is a Windows process and its resources. What is happening? That the process object is going through the virtual address descriptors and the handle table using the access token. Okay. Now, process and thread objects. Windows make use of two types of process related objects, processes and threads. The first one is process. What happens in a process? An entity corresponding to a user, job or application that owns resource. What happens in a process? Any entity which corresponds to a user, job or application that owns that resource. Windows make use of these kind of two type of process related objects. Now, threads, a dispatchable unit of work that executes sequentially and is interruptible. Thread is a dispatchable unit of work. It executes sequentially and it is uninterruptible, which means that you cannot interrupt it in between. Okay. Now, Windows process and thread objects. This at the left hand side you can see there is process object, and at the right hand side you can see this is the thread object. Now, here you can see a process has object body attributes. A process has to have a process ID, a security descriptor, base priority, thread default processor affinity, quota limits, execution time, input output counters, virtual machine operation counters, exception / debugging ports or exit status. Any process will have a process ID with the help of which you can identify the kind of process present which is there. Similarly, a thread will have an object attributes of thread ID, thread context, dynamic priority, base priority, thread processor affinity, thread execution time. There will be execution time whichever in which a thread gets executed will be known as its execution time. Alert status, suspension count will be there. Impersonation token is also an attribute of thread. Thread exit status. Now the services provided by a process are to create a process, to open a process, to query process information, set process information, current process and terminate process. A process will be created first. That is also one of the service provided by the process object, and the process will be have to be opened. Then the query process information will be there. We will set process information then, and then we will terminate process. Now the services provided by the thread object are to create a thread. First, initially a thread will be created, then the thread will be opened. The query thread information will be there. Then you will have to set thread information, current thread, terminate thread, get context, set context. You will have to get context of any of the thread, and that then you will have to set that context. Then suspension of thread will be there, and then you will resume to the functioning of the thread. Alert thread, test thread alert, and register termination port. Now Windows process object attributes. What are the process object attributes of a Windows? I just told you that these were the attributes. Similarly, then we will go through the attributes of thread. Now I told you that a thread has an attribute process ID. What is a process ID? Process ID is a unique value that identifies the process to be to the operating system. How you will identify any process? By using its process ID. Okay. How will the operating system identify the process? Using its ID. Now the other attribute is security descriptor. Security descriptor describes who created an object, who can gain access to or use that object, and who is denied access to the object. Security descriptor describes basically that if who is the particular creator of that object, and who else has the access to the use of object, and how you can authenticate or refuse someone to get access to that particular object. Now the other attribute is base priority, a baseline execution priority for the processes threads. The third one is default processor affinity, the default set of processes on which the processes thread can run. The other one is the quota limits, the maximum amount of paged and non-paged system memory, paging file space, and processor time a user's process can use. These are the quota limits, that how much time a user processor can use. Now the execution time. What is the execution time? The total amount of time all threads in the process have executed. The total amount of time which was taken by all the threads to get executed. Now VM operations count, input output counters. What happens in input output counters? Variables that record the number and type of input operations or output operations that the processes threads have performed. That keeps track of the input output counters, that whatever the input and output operations were performed, you need to keep a track of that, and that is kept in the input output counter. Now VM operation counters, variables that record the number and types of virtual memory operations that processes threads have performed. There must be some virtual memory operations that you may have performed or anyone else may have performed in the processes threads. Okay. So these are the variables that record the number and types of virtual memory operations. Now exception debugging ports. Inter-process communication channels to which the process manager sends a message when one of the processes threads cause an exception. Normally, these are connected to environment, subsystem and debugger process respectively. Now, exception or debugging ports are the inter-process communication channels, okay, which the manager sends, to which the process manager sends a message. When the process threads causing, whenever there is an exception in the thread, process threads, then there has to be a inter-process communication channel to which the process manager can send a message that there has been an exception, okay. Now, normally these are connected to environment, subsystem and debugger processes respectively. Now, the exit status, what happens in exit status? Exit status is the reason for a process's termination. Whenever you terminate a process, there has to be exit status at why the process was terminated. Now, Windows thread object attributes. Previously, we just read about the process object attributes. Now, we will go through thread object attributes one by one. A thread has a ID, thread ID which unique. Now, what can be a thread ID? Just like a process ID, there is the unique value that identifies a thread whenever it calls a server is your thread ID. Now, thread context, the set of register values and other volatile data that defines the execution state of a thread. Those values, register values, or those volatile data that define what is the execution state of thread is your thread context, right? Now, what is dynamic priority? Dynamic priority is that attribute of thread whenever the thread's execution priority at any given moment, okay. Now, what is base priority? The lower limit of the thread's dynamic priority is your base priority. Thread processor affinity, the set of processors on which the thread can run, which is a subset of all the processor affinity of the threads process. What is thread processor affinity? It is a set of, basically it is a set of processors on which your threads are running. Now, it is a subset of all processor affinity of the threads process. Now, what is thread execution time? The cumulative amount of time a thread has executed in user mode and in kernel mode. Whatever time a thread took for execution in user mode as well as in kernel mode is also called as its execution time. Alert status, a flag that indicates whether a waiting thread may execute. An asynchronous procedure call is its alert status. Now, then you have the suspension count, the number of times the thread's execution has been suspended is its suspension count. Now, impersonation token, a temporary access token allowing a thread to perform operations on behalf of other process, which is used by the subsystem, is its impersonation token. Termination port, an inter-process communication channel to which the process manager sends a message when the thread terminates, used by subsystem. Just like in process attribute, we used to have a terminate exception or debugging port. Similarly, there is a termination port in thread. Now, you all must be aware of inter-process communication. Whenever a process communicates with another process, then this kind of process is known as inter-process communication. And whenever a thread terminates, then a process notifies the other process using inter-process communication. So, this channel is known as termination port. Now, thread exit status, the thread exit status identifies or it just presents that this is the reason for thread's termination, right? Now, multi-threaded process. What are the features or what happens in a multi-threaded process? A multi-threaded process achieves concurrency without the overhead of using multiple processes. A multi-threaded process achieves concurrency and there will be no overhead. That is the basic concept of multi-threading. Threads within the same process can exchange information through their common address space and have access to the shared resource of the process. In a single process, if there are multiple threads, they will exchange information how? through there will be a common address space through which they will exchange information, and through that only they will have access to the shared resource of process. Now, threads in different processes can exchange information through shared memory, and that has been set up between the two processes. I just recently told you that what happens in an inter-process communication, one process communicates with the another process. This happens through two ways. One is message passing and the other through shared memory. Now, whenever there are two different threads present in two different processes, they will communicate through shared memory, okay, which will be set up between both of the processes. Now, thread states. This displays that the thread is in a runnable state. First of all, the thread is ready. That is, we can send it to execution. Then it is picked up to run. Then it goes in standby mode. Then we switch to the thread and it gets in running state. Then again it is preempted so that the other thread can enter the process. Now, what happens in non-runnable state? The transition happens and the resource available is sent to the ready state. Now, whenever a process has completed its execution after running state, it goes to the terminated state. Okay. Now, here you can see that the thread was in running state and then it got terminated, right? Now, thread will be blocked or suspended, then it will again go through waiting state, and then when it gets unblocked and it resumes or the resources being available, then it again goes to ready state. Now, let's study more about symmetric multiprocessing support, SMP. Threads of any process can run on any processor. Soft affinity and hard affinity. The dispatcher tries to assign a ready thread to the same processor it last ran on. What does your dispatcher do? It tries to assign whatever the ready thread is there and it assigns it to the same processor on which it last ran on the. It helps reuse of data still in that processor's memory caches from the previous execution of the thread. An application restricts thread execution to certain processes. Solaris process. It makes use of 4-threaded related concept. First one is process. Process includes the user address space, stack and process control block. Now, user level threads. A user create unit of execution within a process. Lightweight process. What are the lightweight processes? A mapping between user level threads and a kernel thread is called lightweight process. Kernel threads are the fundamental entities that can be scheduled and dispatched to run on one of the system's processes. What happens in a process? A process includes the user address space, stack and process PCB. And what happens in a ULT or user level thread? A user created unit of execution within the process. Now, what happens in lightweight process? There is a mapping between ULT and kernel threads. What is a kernel thread? Kernel threads are the fundamental entities that can be scheduled and dispatched to run on one of the system processes. Now, here you can see processes and threads in Solaris. Now, this is your process. There are lightweight processes, a user thread, this is kernel thread, and this is your system call which is being made by the process. Okay? And then there is kernel and then there is hardware. This is your traditional Unix and this is your Solaris. Process structure in traditional Unix and Solaris is there. A lightweight process or data structure includes a lightweight process identifier. The priority of this lightweight process, a signal mask, saved values of user level registers, the kernel stack for this LWP or lightweight process, the resource usage and profiling data, pointer to the corresponding kernel thread, pointer to the process structure. Now, these are the Solaris thread states. First, it was in the run state, then it was in the on proxy, then it got to sleep. Now, this is how you differentiate between an interrupt and a thread. Most operating systems contain two fundamental forms of concurrent activity: processes or threads, and then interrupts. What are processes? Processes cooperate with each other and manage the use of shared data structures by primitives that enforce mutual exclusion and synchronize their execution. And an interrupts are synchronized by preventing their handling for a period of time. What is the solution for Solaris? Solaris employs a set of kernel threads to handle interrupts. An interrupt thread has its own identifier, priority, context, and a stack. The kernel controls access to data structures and synchronizes among interrupt threads using mutual exclusion primitives. Interrupt threads are assigned higher priorities than all other types of kernel threads. Now, this is a Linux task. A process or task in a Linux is represented by a task struct data structure. The structure contains information in a number of categories. Now, this you can see these are the Linux and process or thread model. What are Linux threads? Linux does not recognize a distinction between threads and processes. A new process is created by copying the attributes of the current process. The clone call creates separate stack spaces for each process. User level threads are mapped into kernel level processes. The new process can be cloned so that it shares resources. Now, these are the Linux or clone flags. What happens in a Mac OS Grand Central Dispatch GCD? It provides a pool of available threads. Designers can designate portions of application called blocks that can be dispatched independently and run concurrently. Concurrency is based on the number of cores available and the thread capacity of the system. Now, what happens in a block? A block is a simple extension to a language. A block defines a self-contained unit of work. It enables a programmer to encapsulate complex functions, scheduled and dispatched by queues, dispatched on a first in first out basis, can be associated with an event such as timer, network socket, or file descriptor. So, students, this will be all for today's lecture, and I will be seeing you in next lecture. Thank you very much.